everybody. In these exercises we're just going to be finding some simple volumes of pyramids. Now the formula we need for the volume of a pyramid is 1/3 base times height. You can sort of think of this as 1/3 of a rectangular prism. Alright, and our first one here, our base is a 12 by 8 rectangle. So we'll put that right here, 12 times 8, and the height, as we can see from vertex to the base, is 10. And then putting that in the calculator, we simply have 320 cubic feet. Okay, for number 2, we have a triangular pyramid here. We need 1/3 area of the base. Now if we look at the base, we have a right triangle. We do need to figure out the height of this. We know one leg is 6, the other is going to be 8, because 6, 8, and 10 are a Pythagorean triple. So for the area of the base, we have a triangle. That's 1/2 of its base times the height, 1/2 of 6 times 8. And then the overall height of this is 15. Putting it all together, it multiplies out to 120 cubic feet. Alright, for number 3, another triangular pyramid. We need our formula here, V equals 1/3 times the base. Now, the height, we can take care of that first of all. That's this right here. We kind of have a weird looking pyramid here. It's angled differently. The base is down here, the 8 and the 4 right here. Okay, now this 12 though, that is acting as the height. So we'll have that in. Now we just got to do work to find the area of this bottom triangle here. Well, if we look at it this way, we need to single out one of these right triangles. Okay, and I'll kind of redraw that here. Okay, we know this to be 8. We know this to be 4. Okay, and then we can use Pythagorean Theorem to find this unknown length right here. So I can label it here. Here's x, and here's x here on this one. Okay, so x squared plus 4 squared equals 8 squared. And then solving for x, I believe it comes out to 13.9. The way we got that was we subtracted 4 squared from both sides and took the square root. So this was the result of the square root of 64 minus 16. Now that is going to be our base of the triangle, 13.9. The height, as we can see here, is 4. And then we're taking 1/2 of that to complete the triangle. So all this goes right in here. Putting it all together, 110.9 cubic centimeters. Okay, for number 4, looks like we have a hexagonal pyramid. Now, 1/3 base times height. A lot of work here in the base. The height we see obviously is 18. Okay, each side of this is 6, and what we're going to do is make a triangle just to carve out a little piece of this right here, and we're going to drop the apothem straight down. Okay, now we're dealing with this triangle here. I'll redraw. It's our right angle. Now, all the way around, if we circumscribe the circle, we have 360 degrees. We need to find the area of just this little sector here, 360 divided by 6, that comes out to 60 degrees. That 60 degrees is the top of this triangle here, but here I'm cutting it in half. And now we're at 30, 60, 90 triangle. Alright, now this piece right here is 3. That makes the hypotenuse 6, and the long side, our apothem, what we're after, is 3 radical 3. Alright, so now we can use this to find the area of our base. Remember, we're doing the formula 1/2 pa, p times a, where p is the perimeter, 36, and we just did all that work to find the apothem, which is 3 radical 3. Putting all this in the calculator is going to yield 561.2 cubic feet. And there we are.